Hello and welcome. Today, we're diving into a huge challenge in the software world. How do we actually guarantee quality? It's not just about finding a few bugs on a web page anymore. We're talking about making sure every single piece of a complex application works together perfectly. Okay, let's get into it.
This is the big question, right? When a user clicks a button in an app, a whole chain reaction kicks off behind the scenes. So how can we be absolutely confident that the entire chain, from the stuff you can see all the way down to the stuff you can't, is rock solid? Well, it's because modern software isn't just one single thing. It's a stack. You've got the user interface, then the business logic, the APIs, the databases. They're all interconnected. Just testing the surface is kind of like checking the paint job on a car without ever bothering to look under the hood at the engine.
So here's our game plan. We'll start with the big picture, the full stack challenge. Then we're going to peel back the layers, one by one, from the UI down to the back end. After that, we'll see how to put this whole thing on autopilot before we peek into the future and see where AI fits in. First up, let's really frame the problem here by digging into what we actually mean when we say the quality stack. At its heart, full stack test automation is this big, holistic idea. It's basically a strategy that says, hey, we can't just test things in isolated little boxes anymore. We have to verify quality at every single layer of the application if we want to be truly confident in our product. The best way to think about this is like you're constructing a building. You wouldn't just check if the windows are clean, right? Of course not. You'd verify the foundation, the steel frame, the plumbing, everything. That's our quality stack. Every single layer has to be strong for the whole structure to be reliable.
So let's start building this quality stack from the top down, with the layer everybody sees and interacts with, the user interface.
But here's the thing. Testing a modern UI is tricky. We're not dealing with simple, static web pages anymore. A lot of apps today are so-called single-page applications, where everything happens on one screen. Or they're built from microfrontends, these tiny, independent pieces all stitched together. This super dynamic JavaScript-heavy world can completely break old-school testing methods.
Now, to handle these challenges, a whole bunch of different tools have popped up. You've got Selenium, the long-standing classic. It's a real workhorse for making sure an app works across all the different browsers. But for those faster, more dynamic apps we just talked about, modern tools like Playwright and Cypress really shine because they were built from the ground up for speed and reliability in this new JavaScript-heavy world.
Okay, so we've tested what the user sees. Now, let's go deeper into the stack to what I like to call the invisible plumbing, all that back-end logic. This is really the engine room. This is where the actual work happens. When you click that Buy button, it's the back-end APIs and microservices that are processing the payment, updating the inventory, and scheduling the shipping. If this engine room fails, the whole application fails. It doesn't matter how pretty the UI is. So how do we test it? It's actually a pretty logical flow. An automated test will build a request, just like your browser would, send it off to the server, and then it just waits for the response. The most important part, though, is that final step, asserting or verifying that we got back exactly what we expected to get back. And this testing has to cover a whole range of different technologies. For modern REST APIs, tools like Rest Assured are perfect. But we also have to think about older, more rigid SOAP services that are still super common in big enterprise systems. And then there's the whole world of independent microservices. Each one plays by its own rules, and all of them need to be verified. And of course, beneath all of that logic is the data itself. A single app might be pulling information from a structured SQL database for transactions, a super flexible NoSQL database for user profiles, and maybe a massive data lake for analytics. We have to make sure that data is consistent and correct everywhere it lives, because at the end of the day, an app is only as reliable as its data. So we have tests for the UI, and we have tests for the backend. But how do we run them all together consistently, automatically? Well, that brings us to the pipeline, the true engine of quality. This quote really just nails it. I mean, having tests is one thing, but integrating them into a pipeline that runs automatically every single time code changes, that is how you deliver quality at the speed that modern development demands. This whole process is the heart of what's known as CI/CD, or continuous integration and continuous deployment. It really works like an automated quality assembly line. It all kicks off when a developer commits new code. From there, a build tool compiles it,
And then a CI server like Jenkins runs our entire suite of tests: UI, backend, database, the whole shebang. And here's the golden rule: only if every single test passes does the code get deployed. This is the safety net that makes quality at speed possible.
Okay, on to our final section. We've built our quality stack and we've automated it. So what's next? Well, the answer seems to be making the entire stack smarter with artificial intelligence. And it's really important to see AI as more than just another testing tool. It's a fundamental shift. It really has the potential to change our entire strategy for how we ensure quality, from the top of the stack all the way to the bottom.
So what's the core difference? Well, think about it. Traditional test scripts are rigid. If a developer changes the ID of a button, the test breaks. It needs a person to go in and fix it. AI promises something way smarter: self-healing tests that can actually understand the change. Like, oh, the login button just moved over here, and it can adapt on the fly. This could drastically, and I mean drastically, reduce the amount of time we spend just fixing broken tests.
And as AI becomes a bigger part of our actual applications, we also have to learn how to test AI itself. This means validating machine learning models and even testing the prompts we send to large language models, using specialized tools like PromptVu to make sure the AI is giving us reliable, accurate answers. So, if there's one thing to take away from all of this, let it be this: quality isn't something you just check for at the end of the process. It's something you have to engineer into the system from the very beginning. It has to be a core part of every single layer of your stack, from the first line of code to the final deployment. And that leaves us with a pretty fascinating question to ponder. As AI starts to handle more of the routine, repetitive checks, what becomes the new essential role for the human expert? How do we shift our focus from just finding bugs to actually architecting quality itself? That's the challenge and the opportunity that's going to define the future of this field. Thanks for exploring it with me today.